A water gun is a type of toy gun designed to shoot water. Similar to water balloons, the primary purpose of the toy is to soak another person in a game such as water warfare. Historically, water guns were made of metal and used rubber squeeze bulbs to load and propel water through a nozzle. Traditionally, water guns have worked on the same principle as a spray bottle. The body is essentially a container for water and the trigger is attached to a pump which squirts water out of a tiny hole at the muzzle or nozzle. However, many modern water guns employ more complex technologies to provide more power and water output than their predecessors. Modern variations may employ compressed air, rubber chambers, springs, peristaltic pumps, or hydraulic pressure to propel the water. Some even use an electric pump powered by batteries. Some employ a combination of technologies to produce better stream performance. A common term for large high-pressure water guns is water blasters. For several years in the US and Canada, import regulations and domestic laws have required squirt guns to be made of clear or tinted transparent plastic to make them harder to mistake for actual firearms. Types. Squeeze bulbs akin to water droppers. The oldest known manufactured water guns utilized a simple rubber squeeze bulb into which water could be drawn, then forcibly expelled out the nozzle by squeezing the bulb rapidly. This design has inherent limitations regarding the amount of pressure that one can achieve as well as the need to refill after each shot. Piston/squirt gun. Many early small water guns used the same trigger-based pumping mechanism used for spray bottles. In this type of device, the trigger actuates a positive displacement pump shaft. With the aid of two check valves, often using small balls, fluid is drawn into the pump from a reservoir, then forced out the nozzle upon squeezing the trigger. The simplicity of the spraying mechanism allowed these toys to be manufactured cheaply, and allowed the majority of the body to be used as the reservoir. The primary limitation with this design is the volume of water that can be effectively moved per pump. Increasing pump volume would require more user effort to push the fluid out, making larger designs impractical. However, this technology remains widely used today both in spray bottles as well as small water guns that can be found in a wide variety of shapes and colors. A piston pumper is another version of this system. They are generally bigger than squirt guns and spray bottles. Piston pumpers do not have triggers. Instead, they fire by moving the pump back and forth. Although the piston pumper has greater output than squirt guns, they tend to be less powerful than pressurized water guns. Syringe/piston. Another simple method employed is a syringe or piston type. In essence, the water gun is made up primarily of the pumping mechanism that comprises an outer pump shaft with an inner pump rod and watertight seal. This allows water to be drawn into the pump as the pump is extended, then forcibly ejected out as the pump is compressed. Stream performance is dependent on the user's strength. Some models, like the Super Soaker Power Soaker Junior and Stream machines, draw in and expel water from their nozzles. This design requires a bucket-type filling source. Other models, like the Super Soaker Power Soaker Mighty Cannon and Water Warrior Steady Stream, have check valves and a reservoir for portability. Motorized small piston. During the 1980s, the motorized water gun was perhaps at its most prolific. Companies such as Entertech Incorporated and Lorami Incorporated created water guns modeled after guns popularized in movies such as Rambo. At the heart of these devices was a small motor and crankshaft that converted a rotary motion into a forward-backwards pumping motion to drive a small pump akin to those found in the small spray bottle-type squirt pistols. Stream performance was often not improved, but the motor removed the need to pump, which made the toys popular. The greatest fallback was that they wore out batteries quickly. However, their main strength and consequent reason for dismissal was their realistic styling. After some of these realistic-shaped water guns caused accidental shootings by police, stricter rules regarding shapes and coloring of water guns were drafted in the United States. Air pressurized reservoir. This type was made famous by the Super Soaker brand of water guns, actually first employed by the Cosmic Liquidator. In this device, a pump is used to push air into a partially water-filled reservoir. The reservoir is otherwise airtight, but it has one valve to let the incoming air in from the pump as well as a manually controlled valve operated by the user, commonly activated by pulling on a trigger. As more air is pumped in, the air in the reservoir is compressed, increasing in pressure. The water is also pressurized by the now compressed air. Upon opening the nozzle valve, the pressurized water is pushed out through the nozzle as the air attempts to re-equilibrate with atmospheric pressure. This system allows pumping energy to be stored and used as needed. As well, unlike the methods noted above, this air pressure system allows production of a solid, continuous stream of water. The limitation of this design is the need for a large number of strokes to pressurize a larger reservoir. As well, poorly sealed reservoirs would render a water gun useless. Moreover, these water guns cannot be refilled unless emptied and depressurized. Opening a pressurized reservoir blaster while there is pressure remaining in the system can result in copious local water spray or even an unexpected launch of the water gun and/or reservoir out of one's hands. Air separate pressure/firing chamber equals. The air-based separate pressure chamber or firing chamber system works on the same physical principle as the pressurized reservoir system, but instead of pressurizing the reservoir, a separate, fixed-volume chamber is included on the water gun into which water is pumped, compressing the air inside. This technology was first used on the Super Soaker SS-100. This allows the reservoir to be removed opened at any time for refilling since the reservoir is not pressurized. As well, the typically smaller size of the pressure chamber and the fact that water is typically pumped, as opposed to air, reduces the average number of pumps needed to achieve functional pressure. For improved performance, some users opt to pre-pressurize the firing chamber by pumping in some air first. This increases the starting pressure within the chamber, thus increasing the overall average pressure experienced by the water when it is pumped into the pressure chamber. Split air versus water pressure chamber equals, while air-based, the split air versus water pressure chamber has a sliding plunger that separates the compressed air from the water. This technology has so far only been seen on the Water Warrior's Aqua Master Precharger series. A button is used to toggle whether the pump is priming pre-pressurizing the pressure chamber with air or whether the pump is moving water into the pressure chamber. Akin to pre-pressurizing the separate pressure chamber water guns, the split air/water pressure chamber takes this one step further by preventing the accidental, undesired release of the pre-pressurized air by keeping it separated from the water by a sliding piston divider. After all the water is expelled from the pressure chamber, the sliding piston prevents loss of the pressurized air, thus reducing the number of times the water gun must be pumped in order to achieve optimal firing pressure. Rubber diaphragm/hydropower equals. Hydropower is a term coined by Busby Toys Incorporated, referring initially to their series of water guns that employed an elastic rubber bladder to pressurize water. Akin to the CPS system, the rubber diaphragm system can be considered basically half of a CPS pressure chamber. A sheet of elastic material is clamped against a housing unit. Water is pumped into the chamber, expanding the bladder that pressurizes the water within. However, due to the shape of the bladder, its expansion is not as uniform as in the CPS system, thus it experiences more significant pressure drop-off as the pressure chamber empties. Springs equals. Another means of pressurizing or propelling water used in some water guns is the use of metal springs. The Waterball series has a spring-based catapult mechanisms for launching balls of water out of its nozzle. The Water Warrior's Steady Stream uses a spring-based mechanisms as a sort of water capacitor to allow this otherwise piston-based water gun to produce a constant stream of water so long as the user pumps quickly enough. Additionally, the Super Soaker Quick Blast employs a spring-based firing chamber to propel its stream forward. Peristaltic pumps equals. Peristaltic pump systems have also been used in some water guns models, most notably the original Shield Blaster water guns by Mattel Incorporated. In this system, a rotary pump is used to move rollers along a compressible piece of tubing. As the rollers move, they push water along the tubing. The force exerted by the pump is dependent both on the speed of rotation as well as the thickness of tubing used. True continuous streams cannot be produced since the physical presence of the rollers means there will be partial gaps in the flow. However, If pumping is done quickly enough, the end result is a virtually smooth stream. Hybrid systems There are also a number of water guns that employ a variety of pressurization systems to propel water. See also, water warfare, water balloon, assassin, super soaker, Entertech, water warfare. References. External links, Statistical Database Maximum Range, HydroWar, isoca.com, Super Soaker Central, Water Gun Museum, How Stuff Works, Waterworks, the top 6 water guns of all time.